Hi all, welcome to new class. Let us study about encoders. An encoder is a device whose inputs are decimal digits or alphabetic characters and whose outputs are the coded representation of those inputs. In other words, an encoder may be said to be a combinational circuit that performs the reverse operation of the decoder. And the opposite of the decoding process is called encoding. So, encoding is a process of converting familiar numbers or symbols into a coded format. An encoder has a number of input lines, only one of which is activated at a given time and produces an n bit output code depending on which input is activated. So this is the block diagram for an encoder with m inputs and n outputs. And here the inputs are active high, which means they are normally low. Let us study about octal to binary encoder. A binary to octal decoder accept 3-bit input code and activate one of 8 output lines. That is, in case of 3 line to 8 line decoder, it accepts 3-bit input code and activate one of 8 output lines corresponding to that code. And in octal to binary encoder, that is 8 line to 3 line 8 line to 3 line encoder accept 8 input lines and produces a 3-bit output code corresponding to the activated input. So this is the truth table for octal to binary encoder. These are the inputs, that is here octal numbers 0, 1, 2, 3, 4, 5, 6 and 7 are the input, and only one of these output will be activated, that is according to which input is activated we get the output. That is, if 4 is activated, then we will get the output as 100. So from the truth table we can write A2 equal to D4 plus D5 plus D6 plus D7, D4 plus D5 plus D6 plus D7, and A1 equal to D2 plus D3 plus D6 plus D7, and A0 is equal to D1 plus D3 plus D5 plus D7. Now we can draw the logic diagram, that is the inputs are here D1, D2, D3, D4, D5, D6, D7 are present and D0 is not present. So only D1, D2, D3, D4, D5, D6 and D7 are present in the input lines. So these are the input lines. So here A2 is D4 plus D5 plus D6 plus D7. So A2. A2 we can draw like this, that is OR gate. A2, and it is D7 plus D6 plus D5 plus D4. And next is A1. A1 is again OR gate. A1 equal to D2 plus D3 plus D6 plus D7. D6 and D7. D7. Then D6. D3 and D2. D3 and D2. And next is A0. That is again one OR gate. A0. A0 is equal to D1 plus D3 plus D5 D7. D7. Then D5. D3 and D1. So this is the logic diagram for the octal to binary encoder. Next is decimal to BCD encoder. This type of encoder has 10 inputs, one of each decimal digit, and 4 output corresponding to the BCD code. And this is a basic 10 line to 4 line encoder. So this is a 10 line to 4 line encoder, and this is the truth table. So we can write the outputs A3. A3 is equal to D8 plus D9. Next A2. A2 is equal to D4 plus D5 plus D6 plus D7. And A1. A1 is equal to D2 plus D3 plus D6 plus D7. And A0 is equal to D1 plus D3 plus D5 plus D7. Now we can draw the logic diagram. And here also, while checking, the input lines are D1, D2, D3, D4, D5, D6, D7, D8 and D9. D0 is not included. So D1, D2, D3, D4, D5, D6, D7, D8 and D9 are the inputs. And we can draw the logic diagram. First one is A3. A3 is D8 plus D9. So first one, draw OR gate A3 D9 plus D8. Next is A2. A2 is D4 plus D5 plus D6 plus D7. A2 D7 plus D6 plus D5 plus D4. A1 is D2, D3, D6, D7. So A1 D6 plus D7, D7, D6, D3, D2, D3 plus D2. Last one is A0. So A0 is D7 plus D5 plus D3 plus D1. So this is the logic diagram for the decimal to BCD encoder. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.